Okay, so I just gave you a sheet that says 2 truths and a lie, potential kinetic energy. I want you to put your name at the top and date it. So I'm going to scroll through and I'll read it out loud to you. And you guys have to determine which 2 are true and which one is a lie. The lie you'll mark down on your paper and then we'll go through it at the end, okay? So, the first one, I gotta scroll through these, hold on. Alright, you ready for number 1? Okay. Number 1, which of the following is a lie? Potential energy is stored. A battery is an example of potential energy. An apple falling from a tree is an example of potential energy. Take your time. Which one of those is incorrect? And write it down on your paper.
Yeah. The letter?
Yeah, you can write like A, B, or C. Did you get it? You ready to move on? Okay. Alright. We'll go to the next one. Which of the following is a lie? A stretched rubber band is an example of kinetic energy. Kinetic energy is the energy of motion. A frisbee flying in the air is an example of kinetic energy. Remember, you're writing down the lie. Ready? Okay. Number 3. Which of the following is a lie? Energy comes from one form to another, or energy changes from one form to another, sorry. B, it is easy to create new energy. Or C, a ball at the top of the hill has potential energy. You're going to mark down on your paper which one's a lie. If you don't know, just do the best you can. Try to eliminate. You guys ready for number 4? Okay. Which of the following is a lie? To find the total amount of energy, subtract the potential energy from 100. B, energy is measured in joules. C, the heat radiating from the campfire represents potential energy. This is a tricky one.
Do we learn this?
So we haven't talked about joules. But and we might not have talked about I know that we've talked about potential energy and kinetic energy. It's just we haven't talked about their measurements or their formulas yet. So this one's a little bit harder. Take a guess. You might not know it, and that's okay because we might not have covered all the material. But just take your best guess which one you think is a lie. And we're going to go over them together. Okay, are you ready for number 5? Okay. Alright, which of the following is a lie? A boat moving through the water demonstrates potential energy. A boulder resting at the top of the cliff represents potential energy. Water being poured into a glass is an example of kinetic energy. guys ready? Okay. Number 6. Alright, which of the following is a lie? A, the more mass an object has gives it more potential energy. B, as potential energy increases, so does kinetic energy. C, raising the height of the ramp will increase potential energy. Ready? Alright, number 7. Which of the following is a lie? A, kinetic energy is stored energy. A wrecking ball at the top of the swing is an example of potential energy. C, the higher the wrecking ball, the greater the potential energy. Ready? You know in a second. Okay. Number 8. Which of the following is a lie? A, water flowing over a cliff demonstrates a transformation from potential to kinetic energy. B, energy making a light. Let me start over. B, energy making a bulb light up demonstrates the electrical energy to radiate energy. So that's not something we necessarily have talked about yet, but you can still take a guess at it, whether it's true or not. C, a roller coaster moving down the slope represents kinetic energy transforming to potential energy. Ready for number 9? Alright. If a bike is moved to the top of the ramp from the bottom, it will have more potential energy. B, a stone flying on top of a mountain, or lying, I said flying. B, a stone lying on the top of the mountain has potential energy. C, potential energy cannot be converted into any other form of energy. Ready? Okay, number 10. Which of the following is a lie? A, when an object is at rest, it provides a demonstration of potential energy. B, if during an experiment the scientists change the mass of the object tested, mass is the variable. This one we haven't talked about variables and stuff either. Again, you can read that to yourself and think, does that make sense? Is that true? C, kinetic energy can be seen when a ball is sitting on a tall shelf. Alright, we're almost there. We have 16, we're at 11 now. You guys ready to move on? Okay, now we're at 11. Which of the following is a lie? A book sitting on a tall shelf has more potential energy than one on a lower shelf. When a roller coaster is going up a hill, it is losing kinetic energy and gaining potential energy. A roller coaster has more potential energy at the top of a hill than at the top of a tall hill, a low hill. Let me restart that again. C. A roller coaster has more potential energy at the top of a low hill than at the top of a tall hill. Okay, number 12. Which of the following is a lie? Potential energy and kinetic energy combined equal 100% of the energy in a system. B. Water flowing through a rubber hose demonstrates potential energy. C. As a ball rolls off the top of a ramp to the bottom, potential energy decreases and kinetic energy increases. Okay, number 13. Alright, which of the following is a lie? A. To increase the potential energy in a toy car and ramp experiment, add more books beneath the ramp. B. A stretched rubber band has potential energy. C. Food that we eat is an example of kinetic energy. Alright, number 14. Did you guys get number 13 down? Yeah? Okay. Number 14. Which of the following is a lie? A. Given that two balls are at the same height, the one with the greatest mass has more potential energy. B. Joules is the unit of measure for energy. That's like the same one that we saw earlier, except worded different. C. Apple hanging from a tree is an example of kinetic energy. You guys good on that one? You can tell me to slow down if you need me to. Okay. 15. Which of the following is a lie? A. Energy changing from one form to another is called transformation. B. When an object is in motion, it has potential energy. C. To increase object's potential energy, add mass or increase the height of where it is resting. Ready to move on to the last one? Okay. I'll give you more time if you need it. This mask is driving me crazy. Okay. 16. Which of the following is a lie? A. When a child is on a slide, they have the most potential energy at the bottom. B. As a child climbs the ladder of the slide, the potential energy is increasing. C. The longer the rubber band is stretched, the more potential energy it will have. Okay, that was the last one. Do you guys have your sheets filled out? Okay, let's go over them. Can I get you guys to raise your hands and tell me what you have? hold on, let me go back up to the very first one. And we can look at it again, and we can decide which one is the lie. Oops. There it is. Okay. Raise your hand and tell me which one you have for this. Kamaya? C. Right. So the lie is C. An apple falling from a tree is not the example of potential energy, but it is the example of kinetic energy. Perfect. Good job. Okay. So number 2. Oh, I have to scroll down. There we go. There's number 2. Okay, can I get you to raise your hand and tell me which one you think is a lie on this one? Aubrey? A, yes. So a stretched rubber band is an example of potential energy, yeah, opposed to kinetic. Good job. Okay, number 3. If you don't have the right answer, you can just mark it on there. You don't have to, yeah, you can just, correct yourself. Because this is just for review. All right, we are on number 3. Can I get you to raise your hands and I call on someone to tell me which one is a lie? Kamaya? B. Good job. So B says it is easy to create new energy. Well, it's not, right? Not always. Not most of the time. It's hard to create new energy. Okay. So the answer to number 3 is B. Let's go to number 4. All right. Anybody have the answer to number 4? You want to share? Aubrey?
C.
Yeah, C. So heat radiating from a campfire represents potential energy. It actually represents, what would you say?
Yeah, it is kind of right.
So
You got potential kinetic is the other one.
So what do you want to add to that, Maya? Thermal, yeah. So it's actually not potential. I could see where someone would say it's kinetic, and this is about kinetic. We are reviewing kinetic and potential energy. However, it's really not either of those. It's thermal energy. Okay, so thermal is like heat. So radiation from a campfire would make sense that it's thermal energy, not potential. Okay. So that was a little tricky one because that's something that. This was kind of like a one where we haven't really talked about any of those. You just kind of have to guess which one, but you did good. Got the right answer. Okay. You know more than you think. Number 5. Anybody have the answer to that? Someone I haven't heard from yet? Good, Kamani? Yeah. Okay, so a boat moving through the water demonstrates potential energy. It doesn't represent that or demonstrate that. What does it demonstrate?
Kinetic.
Yeah, kinetic energy. Perfect. Okay. So number 6. All right. So which one is a lie? Anybody think they have the right answer? You want me to go? I'll go. I'll take a turn. Miss S. Miss S takes a turn. Okay. Number 6. Unfortunately, well, probably fortunately for all of you guys, your benefit, I have an answer key. So I'll tell you that number B was the lie. So as potential energy increases, so does kinetic energy. I don't know, do you guys remember the Bill Nye video that we had? He talked about that, how as potential energy increases, so does kinetic, which isn't true because if you have potential energy increasing, then your kinetic energy isn't being used yet. So they don't correlate like that. So does that make sense? Okay, am I making sense to you?
Yeah.
Alright. Alright. Number 7. Raise your hand if you think you know the answer to number 7. Which one is a lie? Maya? Okay. A. Yeah. Kinetic energy is stored energy. Kinetic energy is not stored energy. Kinetic energy is moving energy. So that is a lie. Alright, number 8. Okay. Anybody think they have the answer to number 8? Allie, Elijah, do either of you want to share? No? Okay. Give you another second to read it.
C?
Yeah, good. Good job, Aubrey. It is C. So a roller coaster moving down the slope represents kinetic energy transforming to potential energy. So if you have, look at a roller coaster, so you have a slope, okay? And if the little roller coaster, the box, is already halfway down the slope, so here's your slope, here's your cart. If it's going down, it is using kinetic energy, but is it increasing its potential energy? No, because it's going down to the bottom. Where would the biggest amount of potential energy be in this roller coaster? At the top. Right. Okay. Good job. Number 9. Anybody think they have the answer to this? Yeah, go ahead.
Oh, mine's wrong. I know it's wrong.
You know it's wrong?
Yeah, I know
What do you
it's wrong
have?
now. I see that. That's
No, you're right. C is the correct answer. So this is kind of a tricky one. So what? Do I keep saying that? You're
no,
laughing at me?
I didn't know she put on a sweatshirt.
Oh.
I just realized that.
You're cold? I'm kind of not. I'm like ready to go swimming or something. Alright, so yeah, you're actually right with number 9 is C. Potential energy cannot be converted to any other form of energy. So if you have all this potential energy, you're saying it could never be, that's a lie, because think about the roller coaster. If it's at the top, it has potential, in it, you're saying it can't be transformed into any other energy. But we know that's a lie, because as soon as that roller coaster starts going down that slope, then you have kinetic, right? So you just transformed potential into kinetic when you went down that slope. Does that make sense?
Mm-hmm.
Okay, so yeah, you're right, you had it. Alright, number 10. Number 10, anybody? You guys have got it all right so far. I'm like waiting for someone to get it wrong. I don't know if that's okay to me to do. I don't know, but I'm waiting. Like, there's no way. You'll know all these answers. Okay, Kamani?
C?
Oh my gosh, you got it right. Yeah, so C. Kinetic energy can be seen when a ball is sitting at the... Whoa, hold on. Kinetic energy can be seen when a ball is sitting on a tall shelf. No, right? What would that be? How do you make that statement true? If a ball sitting on the top of a shelf.
Potential energy.
Very good. Right, the potential energy. God, blowing me away. I'm surprised. Well, I'm good. There we go. Okay. 11. We're almost through this. You guys have impressed me, so I'm thinking someone in the next couple of questions has to get one wrong. So number 11. Is this going to be the one? It's going to be the one? Who's going to tell me the wrong answer? Aubrey?
Okay. I said A.
You said A. Oh, look at that! We have a wrong answer, folks. I love it. No, and I love it because you know why? Because then other people get to learn from that. That's great. Okay, so it is not A. It is, Kamani, C. Okay, So a roller coaster has more potential energy at the top of a low hill than at the top of a tall hill. That one kind of threw me off even when I was reading it because you're like, wait, what? Yeah, that sounds true. But it's too many hills going on. A roller coaster has more potential energy at the top of a low hill than the top of a tall hill. That's not right because think about, here's my tall hill, here's my low hill. If you got a roller coaster sitting on top of which one's gonna have more energy? The big one, right? So that is what makes C the incorrect answer. This always makes me feel weird doing this because I'm like, usually like you want to find the right answer, not the wrong one. So it's like you have to like really process it, but I like it. You guys have done great, fabulous. Okay, number 12. Anybody? Kamaya? B. Good job. Okay, water flowing through a rubber hose demonstrates potential energy. Well, if it's flowing through the hose, probably not, right? It's going to be kinetic. What if we kinked the hose? Potential, right? And then when you unkink that hose, what does it do? It's like everywhere. So, yeah, good job. 13. All right, anybody? 13? Come on, you had your hand raised last time. You got it this time? No? It's okay. I told you all I'm waiting for y'all to get it wrong. A bunch of smarty pants.
Oh, is it A? No.
Not A, not A. So A is true. Yeah? Huh? Go ahead, what'd you say?
I was gonna say C.
C is incorrect.
It shows rubber band has potential energy. Is that A? Is it B? Is it supposed to be A?
It's the incorrect, the lie is C.
Oh.
I thought you said she got it wrong or something. Like,
That's what I thought she said.
Hold on, y'all are confusing me now.
I'm very confused. Because
Me
you said,
too.
because when I said C, it sounded like you said I got it wrong.
Oh, I thought someone said B.
Oh, no.
Oh, I'm
yeah, well,
lost.
she didn't see what
Okay, so the answer to 13 is C. Sorry, I thought I heard you wrong. That was my fault. So, food that we eat is an example of kinetic energy. No, it's not right. It's not an example of kinetic energy. It's not even an example of potential energy, so.
Isn't that chemical?
Yeah. Yes, you could call it, well, or I think some people call it mechanical energy too. It's like you're eating mechanical, I don't know exactly. I'll get back to you on that. Okay, number 14. Alright, number 14, anybody have an answer? Kamani?
C.
C, that's correct. An apple hanging from a tree is an example of kinetic energy. It is not. If it's just hanging there, then it's an example of potential. If it were falling, then it would be kinetic, right? Mm-hmm. Right. Number 15. Okay. Anybody have an answer? Kamaya?
B.
B, right. When an object is in motion, it has potential energy. That's the opposite. We know that if an object is moving, it has kinetic energy. And last but not least, let me change this one on the screen. What do we have? Kamani?
A.
A, correct. When a child is on a slide, they have the most potential energy at the bottom. Just like the roller coaster, if the child is anywhere, the most potential energy they're going to have is all the way top. Okay? Not at the bottom. Very, very good. I can turn this recording off now. You guys did great.